everyone. Hope everyone's doing well today. Just give me a second to pin up the slides real quick as well. I think hopefully I am audible and visible, and the slides are visible as well. If anyone wants to, chat a little bit or just ask any questions, since we have 5 minutes until the session starts, please feel free to drop your questions or any other messages in the general chat on the Altered Security Discord server. Okay, thank you very much, the Art42. All right, great. Let's just wait for a couple more minutes until we, until we reach the time, and we let some other people join in as well. Since we have a little bit of time, is anyone on the call currently, familiar with COM programming or has abused COM in their previous engagements or in a lab before? Please let me know in the chat. Sorry about that. You see. Okay, so I think if whether you have used it before or not, I think hopefully this talk will serve as a nice mellow introduction to component object model and how you can use it for stealthily execution within environments. At least I'm hoping that this will serve as a good introduction to becoming comfortable with COM. And of course, we have some advanced techniques mentioned towards the end as well, and detection sections as well, but we'll dive a bit deeper into it later. All right. So I think we're right on time. So let's get started with the webinar. So let me formally start with the introduction of the webinar. So hi everyone, and welcome to Position Compromised Weaponizing Windows COM for Stealth Execution webinar by Altered Security. Now this webinar is part of a month-long event called Altered Security Hacker Summer 2026. This is the second webinar of the series. Now there was another webinar earlier last week, which was hosted by our founder Nikhil Mittal, focused on evading Microsoft Defender for Identity. Now, if you haven't attended the webinar or looked at the board yet, I highly recommend that you go through it. There are many interesting insights on evading Microsoft Defender for Identity, including a very new one, which is EDR choker to sort of cripple Microsoft Defender for Identity. So some really cool insights in that talk. So I highly recommend that you check out the Altered Security YouTube channel and take a look at that VOD. And then let's get started with our current webinar. So before we start with the webinar on COM, a little bit about myself. I'm a security researcher at Altered Security, where I focus on on-premises security research, specializing in Active Directory attacks, evasion techniques, malware development, and reverse engineering. Now you can find me on my LinkedIn with the link that is mentioned in the slides, and I'm always open to a conversation about anything security. Apart from my technical research, I've also delivered trainings at multiple conferences like DEF CON, Black Hat, AltSecCon, and more. Now, a little bit about the organization. So Altered Security is a leading organization in cybersecurity training and research labs. We have trained more than 50,000 security professionals across over 130 countries, helping them develop advanced cybersecurity skills and improve their offensive and defensive capabilities. Now, our Red Team Labs platform focuses on affordability, easy access, stability, a great user experience, and engaging challenges that provide hands-on enterprise scale scenarios to prepare professionals for real-world security challenges. Now, coming to the event that you are currently attending right now, and that is the Altered Security Hacker Summer. So, just like I mentioned earlier, the Hacker Summer is Altered Security's month-long red teaming event. Now, this is primarily focused on interacting with our community, right? Developing more relationships with our community and sharing our research all together. So, in this month-long event, you'll see multiple webinars. There are multiple webinars coming up as well, which are going to be focused on red teaming for on-prem environments, Azure environments, as well as upcoming AI red teaming techniques as well. So apart from just the webinars that are hosted by the security researchers at Altered Security, we also have CFPs or call for papers issued for our community as well, right? So we have so there was the call for papers is currently closed, right? It has been completed and the winners have been selected. But apart from the webinars hosted by the security researchers from the organization, you'll also see upcoming public research from community researchers as well, right? And those researchers have been given a sort of a bonus as well as a free course, a course giveaway as well, right? For their contribution to the public security research. Now, apart from the webinars and the research, we also have multiple discounts and giveaways that are going to be hosted throughout the month as well. So please make sure to keep a track of the Altered Security LinkedIn and Twitter pages, and yeah, make sure to enroll yourself into these giveaways. So coming to a couple of ground rules regarding this webinar. Now, since this is a public webinar instead of a privately held class, right? We have disabled microphone access and camera access for participants on the call, right? So that we can keep the session a little bit smoother with regards to the experience. And if you want to ask any question, you can ask it in the general channel of the Altered Security Discord server. Please note that we won't be monitoring the Zoom chat. So instead of dropping a message there, make sure to drop your questions in the general chat. Now, again, please make sure to maintain a professional conduct during the webinar. Now, coming to the agenda that will follow throughout this webinar, let me just get some water first. Okay. So, coming to the agenda that we'll cover throughout the duration of the webinar. We'll first start right from scratch. We'll cover a little bit of COM fundamentals, then why COM even exists. Then we'll dive into the COM architecture, how COM works internally. Then we'll talk about the COM execution flow and how activation works in COM. Now, of course, we want to target COM objects as well. So we'll be covering some techniques to enumerate COM objects in your Windows environment. Then we'll discuss multiple abuse vectors to abuse COM for execution, as well as persistence and a little bit of risk as well. Now, after we have covered these abuse techniques, we'll dive into some detection techniques for our fellow blue teamers as well. Of course, since there are thousands of COM objects that could be present on a Windows machine, it becomes very important to keep a track, from a blue teamer perspective. So we discuss some detection techniques or logs to look out for. And finally, we have some topics for further studies that we can look into for further studies. For example, your cross-session activation and decom, right? We'll gloss over those techniques a little bit so that you can implement those later on for further evasion. Now, coming to what is COM. So let's start with the absolute foundation. Okay, what actually is COM? Now, you can think of COM as the universal translator and the structural glue inside the Windows operating system. So it is you could think of it as a binary interoperability standard. And what this basically means in plain English is that it allows completely different pieces of software to talk to one another and share their features and execute tasks, even if they were written by different developers using different programming languages, and they are compiled at completely different times as well, right? So it basically allows your software components to interact with each other. So, for example, let's say when you drag an Excel chart directly into a Word document and it updates live, or let's say when a script interactively controls, sorry, just a second, just give me a second. All right. Okay, so let's continue. Sorry about that. Yeah. So let's say, for example, uh, when you drag an Excel chart directly into a Word document and it updates live, or for example, let's say you right click in your Windows Explorer, right? And you see the 7-zip option mentioned over there as well, right? That is the COM architecture handling the underlying handshake behind the scenes, right? So it abstracts the language barriers so that the operating system can treat everything as reusable or modular blocks. Now, back in the early days of Windows development, if you wrote a useful library in C++ and let's say your colleague wanted to use it in a Visual Basic application, they ran into a massive wall over there. So, for example, you face some compiler dependencies, right? Or memory management structures didn't line up properly, right? So the application would simply crash in that case. Now, this directly resulted in something called a DLL hell, right? Because the developers had to craft a DLL, you know, very catered to a third-party component, right? Where you want to interact it with, right? Now, COM solved this problem by establishing strict immutable binary interfaces, right? So it created your API or application binary interface, which allowed these components to interact modularly by following a strict guideline, right? Using interfaces. Now, what benefits does COM offer or why it exists? So, as we discussed, uh, the first is that it allows components to be written in multiple languages to interact with each other, right? So, for example, your components written in C++, C Sharp, Visual Basic, PowerShell, and anything at all can interact with each other, right? Another great benefit was component reusability, right? Now, this brings basically your plug and play architecture to software development. Now, since COM relies on these strict interfaces, the underlying logic of a component can completely be swapped out, patched, or upgraded without ever needing to touch or recompile the main application that relies on it, right? So let's say, for example, you have multiple components that are reliant on a particular library, right? And you want to update that library, right, in the operating system. Now, of course, if you update that library, it might break the functionality of a certain component, right? However, COM solves this, right, by 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 restricting them to follow a certain structure, right? And That way, even if a component is being upgraded, right, the clients that are dependent on that component will not break at all. The third benefit is transparent inter-process communication. So COM completely abstracts where a binary is physically executing, or your DLL or your EXE, right? So COM basically uses your DLLs and EXEs behind the scenes as a COM server, right? And the COM architecture hides the location of binaries from the client that is executing, right? So basically, when a client requests a COM object, it does not need to know if an object is an in-process DLL or an out-of-process executable, right? It loads direct, right? Now, this is completely handled by the COM architecture itself, right? The client will issue the same exact code, whether it's a DLL or an EXE. The client will issue the exact same code to interact with the COM server, right? Regardless of whether it's a DLL or an executable. Now, this allows the operating system to isolate these unstable components in their own standalone process so that if they crash, they don't take the entire parent application down with them. Now, there are a couple of key terminologies that we need to discuss before we dive deeper into the COM activation flow or its execution flow. So the first thing is interfaces. Now, as I discussed, that COM servers are essentially DLLs and executables, right, which expose functionality behind the scenes, right? Now, these functionalities are exposed through interfaces. And this interface is a defined group of related virtual functions which a COM class implements. Now, this interface basically points to a V table or a virtual function table, right, which stores the addresses to all of the functions that are being implemented by the class itself. Okay, so the interface basically points to a table which has the addresses of all of the functions that are a part of our COM class. Then we have the object. So whenever we want to interact with a COM class, we don't interact with it directly, but rather we instantiate, right, or initiate an object of that COM class, and then we interact with it to invoke whatever method that we want, right? So we first need to create an object of that COM class, and that is done through the co-create instance function, right? That is used to instantiate the COM class. Now, in our Windows operating system, the COM class is actually identified by a 128-bit GUID, which is called a CLS ID or the class ID, right? So this is basically its unique identifier. Now, just like there is an identifier for the COM class, there is an identifier for each interface as well, and that is the IID or the interface identifier. Now, as we discussed that the Windows environment recognizes a COM class through its CLS ID, right, or its class ID. But as a developer, keeping a track of all of these GUIDs is going to be very difficult, right? You can't, memorize these 128-bit GUIDs to see which COM class you want to interact with. So these COM classes which have a CLS ID also have a string counterpart, which is called a prog ID, right? So for example, this wscript.shell, right? And we'll see an example of our custom COM class as well later on. But essentially, the prog ID is just a string counterpart of our CLS ID for easier developer use. And finally, we have apartments, right? So of course, these COM servers, which are your DLLs and executables, these need to be instantiated, so they need to be executed as well, right? Now, these need to be executed in a safe manner, right? And for that, we have apartments. So apartments are your logical execution containers, right? Which contain, these are basically your containers for your COM servers, right? So whether it's a DLL or an executable or anything else at all, right? Now, these are responsible for multiple things. For example, thread safety and concurrency, right? Maintaining the queue of the actions that are being performed. But we'll dive more into apartments a little bit later on. Now, coming to a little bit deeper, let's talk a little bit deeper about interfaces and vtables, right? Or virtual function tables. So a COM object never exposes its raw code directly to a client. Instead, it exposes its functionality through a very strict and predefined contract called interface, right? So interface is responsible for maintaining this functionality right through the vtables. So the COM interface or the COM interfaces are actually represented by a C++ structure, which is a pointer. And this pointer points directly to a table of another function pointers, right? This table, again, as I mentioned, is called the virtual function table. And this V table is essentially an array of memory addresses. Now, each index in this array points directly to the entry point of a specific function which is compiled in our DLL or executable, right? So again, interface has pointers, right? The pointer points to a table of points to the virtual function table, right? And this virtual function table has addresses of the functions, right? Present in DLL or executable. So what happens when a program actually calls the method? The client application takes its local interface pointer, it traverses it to find the base address of the object's virtual table or the V table or the virtual function table, and then it calculates the exact offset for the method it wants to execute, right? And once it resolves that final memory address, the client process executes a direct jump call straight into the function code running inside that server binary. Okay. Please let me know if there are any questions. Oh, is the presentation not visible? Oh, okay. Now, so we have an idea of what interfaces are, right? And what their purpose is. However, there is one particular interface that is very important. So every single COM interface in the entire Windows ecosystem is required to inherit from a base interface called the I unknown interface. Now, this I unknown interface is actually used to create sort of a universal baseline. You could think of it as that, right? Let's say your C program, for example, has a base structure, right? You have your main function, right, where you need to return a value. Just like that, every interface needs to inherit from a particular interface, which is called the I unknown, right? Now, this sets up your universal baseline for your interface code later on. Now, because of this, whatever vtable, right, your interface might have, its first three slots, right, for your methods. So when I say slot, a slot is a slot for a function, right, in your vtable, right, where the addresses are stored for your function. So due to the presence of this I unknown interface, the first three slots are taken up, right, for the core method, for the core functionality that I unknown brings to the table, right? Now, the first method, and which is the most important one as well, is the query interface method. Now, this query interface method takes a globally unique interface identifier, or your, of course, your the identifier of your interface, right? And it takes it as a parameter, and it returns a pointer to the requested interface, right? So basically, all it's be responsible for is that it takes the IID, right, or which is the GUID of your interface, right, the interface identifier, and it finds the pointer to that interface address, right, so that you can actually access its ABI, right? Now, there are two more functions, right, and these two are responsible for memory management in some sense, or you could say reference counting. So think of it this way. Now, because these COM components are designed to be shared across completely independent clients, right? Let's say multiple clients can interact with a single COM object, right? So Windows faces a challenge over here. How does it identify whether it's safe to destroy the object without actually crashing the program that's still using it, right? I mean, let's say, if how will Windows identify that, okay, it's safe to close, it's safe to destroy the object, right? What if some other program is still using it, right? And for that, these address and release functions are used. So whenever a new client connects to an interface, right, or it duplicates a pointer, it triggers the address function from the unknown interface, right? And this basically bumps the internal counter by one, right? So this basically maintains a track of how many clients have connected, right? Or how many times a client has how many clients have connected to the object, right? Uh, and this keeps increasing one by one, right? Um, and just like that, uh, the release method does the opposite of this, right? It decrements the reference counter, right? Whenever a client, um, let's say whenever a client is done with the object, it calls release, and then it drops the counter by one by calling the release function, right? And when the counter drops all the way to zero, that means that nobody else in the operating system is using this object, right? So that means that it is completely isolated. And then the operating system triggers the cleanup, right? And it removes the instantiated object from memory. Okay. So this is the purpose of the unknown interface. Now, there is one really important component when it comes to the COM model, and that is registry, right? Your COM architecture is heavily reliant on using registry. It stores quite a lot of information when it comes to um, your COM objects, COM classes, and interfaces as well. So, first of all, the pretty much all of the information for the COM structure is stored in the HKCR or HKey classes root hive, right? Remember, and just like we have the HKCU, HKLM, right? Just like that, we have the HKCR or the HKey classes root hive. Now, within within this, so this hive is actually a mix of both HKey current user as well as HKey LAN manager, right? So the HKCR is a mixture of, it basically points to your both HKCU as well as HKLM. Okay. Now, there are certain important subkeys within this HKCR uh, registry hive. So the first one is the CLS ID, right? Whenever you want to see any COM objects, all of the COM objects are mentioned with their GUID within the CLS ID key, right? So this basically acts as a database, right? It contains the information about the CLS ID and what binaries are associated with it as well, right? So within this CLS ID and GUID, you'll actually see the in-proc server 32 or local server 32. We'll go into that a little bit later on, but it essentially stores subkeys like in-proc server 32, which points to the DLL, and local server 32, which points to the executable, whatever you are using, right? So this basically provides you with a mapping for the GUID to the actual exec binary that is being used to instantiate the COM server. Then, just like CLS ID, we have GUID, we have the registry key hive for interface as well, right? We have individual GUIDs or the IIDs, if you'll recall, for interface, right? And that you can find in the /interface key, right? Now, this is in particular used for marshalling. Now, I'll dive a little bit deeper into marshalling a little bit later on, but it's essentially used to serialize the data in a particular byte stream so that it can be transferred to different interfaces, right? So that it can be sent to different components as well, right? So it basically converts converts the data that is being passed into a serialized byte stream. Now, what does the proxy and stub mean over here? So your interfaces will have, so for example, I'll cover this a little bit later, a little bit deeper in the context of tree test hijacking later on. But essentially, these proxy and stuff basically capture the data. Let's say your client is sending the data to the interface. The proxy will capture it over here. It will convert the data into the byte stream. Then another interface will capture it, and then it will go to the COM server. So it's something like this. Now, next, we have another registry key hive, which is the app ID. Now, this basically determines the security configurations for your out-of-process executables, right? So, for example, so there are two types of hosting your COM server, primarily your in-process server, which basically means that it utilizes a DLL and the server is hosted within the client application itself, right? Let's say my PowerShell.exe is trying to access a COM object with a DLL. That DLL will run within the process.exe. It will be loaded by it. But in case of out of proc, a completely new executable will be spawned, right? For example, by svc host.exe, for example, right? If it's a service binary, it will be hosted through svc host.exe or completely separately altogether. Now, app ID is responsible for managing the security configurations related to the launching of this executable over here, right? What impersonation rights are present to run this executable, what ACLs are present, right? If someone is allowed to run this binary or not, and things like that. And finally, we have the type-lib registry key. Now, this is not too important when it comes to security perspective, but essentially, this type whenever we register a binary as a COM class, right? We often convert it to something called a type library or a .tlb file as well, right? Or a type library metadata. Now, this has a lot of metadata regarding our binary, right? That we have assigned as part of our COM server, and all of this information is stored in this type registry key hive. Okay, so as I said, now as we discussed, the first, let me just go back to the slide. So the first and the most important registry key hive for our purpose is the CLS ID registry key hive, right? Now, within the CLS ID, there are multiple registry keys, as I mentioned earlier as well. The first one is the inproc server 32. So whenever now this is the most common implementation of implementing a COM object, right? You will see this very often. Now, whenever this inproc server 32 key is present, right, it points to a DLL file on the file system, right? This is it maps the COM GUI, the COM class to a DLL file, and this tells the operating system that the COM object or the COM component is an in-process server, which is packaged as a standard DLL. Now, inside this key, you will find the value again, which is pointing to the DLL path on the disk, right? And whenever an application requests this object, the Windows COM runtime reads that path and loads that DLL directly into the virtual memory space of the host application itself, right? So whatever application is hosting, requesting that COM object, right? The DLL will be loaded in its memory. Now, it has its own benefits, of course, right? Since it is very quickly loaded, it is very fast in practice. However, there is an issue with using Inproc server 32 sometimes as well, right? Because if the DLL crashes, it will also crash the parent process as well. And this also becomes a primary target for your COM hijacking attacks as well, right? Since untrusted paths can often be loaded into high privilege process, right? Of course, you can modify the path of the DLL file, for example, in the in proc server 32, for example, right? And it could be possible that a high privilege process is going to load a malicious DLL, right? So it can become an interesting target. That is why there is a separate um, class of abuse for this called in proc server 32 hijacking. Now, the sibling to the inproc server 32 key is the local server 32 key. Now, this key indicates that the COM component is an out-of-process server, which is packaged as a standalone executable. Now, when a client calls a CLS ID, which uses the local server 32 path, the Windows operating system does not load any code into the client's memory. Instead, it spawns an entirely separate process on the system to host that object. Right? Now, this of course provides a massive stability boundary, right? So for example, if the COM server crashes, it does not take down the client application with it, right? So this helps in maintaining the stability much more better. Now, from a security perspective, this process creation boundary is actually a very critical telemetry point, right? Since the executable is being spun up as a completely new process, right? So this will definitely leave process creation logs as well, right? So the abuse becomes a much more detectable over here, for example, right? Because your executable will be spawning as a completely new process, right? And those process creation logs can be used by the defenders. Now, the third key of interest in the CLS ID is the tree test. Now, tree test is a completely different type of concept. So what it does is essentially it targets a completely different CLS ID, GUID. So what is to make it a little bit easier to understand, the tree test value essentially points a CLS ID to another CLS ID, right? So for example, I have a COM class hosted on A1, A2, A3 GUID, something like that, right? I can set the tree test key for that GUID and point it to, for example, B1, B2, B3, sort of that GUID, right? So when that COM class is instantiated, right, or when that COM object is triggered, the tree test will actually redirect the execution from the primary CLS ID to the second CLS ID, right? So it is basically used for redirection to another CLS ID, right? Now, of course, this can very well be used by attackers, right? Especially for persistence as well, right? You can have a benign, uh, you can have a benign COM object, right, with a CLS ID, right? And instead of modifying its in proc server 32 or local server 32, you point it to another malicious COM object that you just created instead, right? And that gets triggered. Now, what you can also do is, in this case, for persistence, you can maybe target some sort of COM object that, let's say, triggers every time whenever a login happens, or for example, whenever someone right clicks on Explorer, right? So that will help you establish persistence much better. And finally, the fourth registration key again is the prog ID, right, which is again the human readable string, which maps to our GUID instead. Now, coming to how a COM object is instantiated, or how do we interact with a COM object, right? Now, this is very often called the COM activation flow, right? So, as I mentioned earlier, whenever whenever a client requests a COM object, right, or whenever you try to interact with a COM object, we never interact with the component binary directly, right? Instead, we talk to the COM runtime, right, and it instantiates an object of that COM class, right? So how does the process go about? Well, first, the client actually calls the co-create instance function with the CLS ID of the class that we want to target. The COM runtime maps back to the CLS ID through the registry configuration, right? So as we discussed, right, the CLS ID in the registry key, right? The CLS ID points to the binaries, right? The executables in proc server 32 or local server 32, right? So whenever co-create instance is called, right, the co-create instance, the Windows COM runtime sees the CLS ID, and then it starts mapping that CLS ID to the executable or the DLL or the exe through the registry configuration, right? Now it identifies whether it's an in-process or an out-of-process COM server, right? Whether it's a DLL or an executable, and then it loads the binary into the appropriate apartment space, right? Depending on whether it's a DLL or an executable. And this is sort of what it looks like diagrammatically, right? Your client application, it calls co-create instance, right? The COM runtime triggers, it queries the registry, specifically the CLS ID within the HKCR or the HK classes root hive. And then it identifies whether it's in proc server 32 or local server 32, right? Whether it's a DLL or an executable. And then it simply loads the server binary into the apartment, which is, of course, your apartment, right? Which is just your container, right, to execute your server. So let's dive a little bit more deeper into the two deployment models for COM, right? Let's first start with our in-process COM. Now, whenever a COM component is registered as an in-process server, again, it lives as a DLL, right? Just like we discussed. And when the COM runtime activates it, that DLL gets mapped directly into the virtual memory address space of the client application itself. Now, again, the advantage over here is the raw performance, right? Since the client and the server are sharing the exact same memory space, calling the method is lightning fast, right? It essentially becomes a direct local function call via the vtable, right, or the virtual function table. Now, again, the problem over here is that we lose the sandboxing isolation, right? If that COM DLL, experiences any memory corruption, right, or if it crashes, it poisons the host process, and then it crashes the entire application along with it. Now, furthermore, since it executes our process's memory, their COM server also inherits whatever access tokens and privileges our client application has as well, right? So that can be a security, giveaway as well. Now, on the other side, we have the out of process COM server, right? Over here, it is the COM server is packaged as a standalone executable, and it runs in its own distinct process space, right, on the operating system. Now, whenever the client wants to talk to this object, it needs to cross an explicit process boundary, right? It needs to jump over the apartment container. Now, to make this happen safely, Windows wraps this communication through local remote procedural calls, right, or RPC. Now, this gives a strong security, provides a strong security boundary, right? And if, let's say, your server executable crashes, your main client application remains perfectly safe and functional. Now, the downside over here, of course, is the performance overhead, right? Or the performance loss. Every time the data crosses, in between the server and the client, Windows needs to perform the serialization process, which is called marshalling, as we discussed earlier, right? Uh, for marshalling, it needs to, pack up your function parameters, and then it needs to translate them to a universal format to cross that gap and then unpack them on the other side as well, right? So this definitely adds, latency, but we definitely, but it's somewhat worth the price, right? When it comes to with stability and isolation. Now, let's talk a little bit deeper about com apartments, right? Of course, they're a big part of the conversation, right? They're responsible for containing the execution of a com server. So apartments are actually a logical boundary, right? Which is drawn around a com object by the operating system, and this enforces synchronization, concurrency, thread safety, quite a lot of stuff. Okay. Now, there are three types of apartments in particular. The first type is the single threaded apartments. Now, this is sort of, you could think of the traditional model, right? Which is heavily used by user interfaces and legacy applications. So, in the case of single threaded apartments, an object is actually tightly bound to one specific dedicated thread, right? So you only have a single thread which is executing your server code, right? Now, only and only that thread is allowed to touch the object's memory, right? If, let's say, there is another thread, right, that wants to call a method with on that on that object which is present in the single threaded apartment, the Windows operating system actually intercepts that request, and it forces it into a Windows message queue, right? So it adds it into a queue, right? So that it can be executed later on. Now, next we have the multi-threaded apartments, or MTA. Now, this is a much high performance model, right? Which is built for modern background services and server applications. Now, within multi-threaded apartments, there are zero thread restrictions, right? Dozens and multiple completely different threads can pile into an exact same object simultaneously to execute tasks, right? You can have as many threads as you want. Now, this does, of course, unlock massive performance boosts, right? And it eliminates the serialization or the marshalling problem as well. Um, However, it also strips away the safety net as well, right? In case of multi-threaded apartment, the concurrency and the thread safety is the responsibility of the developer themselves, right? The developer needs to manually implement code level synchronization, all the mutexes, locks, semaphores, right? All of that needs to be taken care of by the developer, right? If you don't, of course, these concurrent threads can potentially corrupt the structure of the object, right? And it might cause unpredictable crashes. And finally, we have the neutral apartment, right? So neutral apartment, or NA. Now, this was introduced quite later to solve a performance bottleneck, which was found in both single-threaded apartments as well as multi-threaded apartments, right? So think of it this way. Normally, whenever a thread from one apartment calls an object inside a different apartment, when the Windows operating system needs to halt the execution and perform the thread context switch, right, from one apartment to the another apartment, right? Uh, Now, the neutral apartment solves this problem, right? It solves the latency problem that is being added through this context switching, right? So the object, uh, so a COM object which is present in a neutral apartment does not have a thread affiliation. You could think of it as that, right? Let's say whenever, let's say a thread calls an object, right? The caller's thread temporarily adopts the object and executes the code directly, right? So there is no context switching required at all, right? Even if you are in, even if you are interacting between different apartments, right? The caller temporary uh, for a temporary duration, it adopts the object and executes the code directly itself, right? There's no marshalling going on over here again, right? It essentially gives the speed of the multi-threaded apartments, right? But it allows the object to respect the synchronization requirements as well, right? Of whoever called it. Okay. Now, coming to why apartments really matter in case of your COM architecture. So, of course, we have just glossed over these reasons a little bit, right? So let's just talk about them a little bit deeper. So first is, of course, that apartments sort of act as a protective firewall, right? They isolate these objects into their own logical containers, and they ensure that no matter how chaotic it might get, right, or how multi-threaded the calling might get, right, the object inside receives the data exactly how it expects to handle, right? So it keeps it safe that way. Then we have synchronization. So in an ideal world, developers would write flawless multi-threaded code, right? Multi-threaded mechanisms for every piece of code, right? But the reality is much more different, right? The writing thread-safe code is very difficult. So uh, COM really takes the burden of the programmer by handling this synchronization at the operating system level, right? And it completely depends on depending on the apartment type which has been declared while you register your object. Windows automatically sets up the sort of, you could think of, rules of engagement, right? It completely uh, you know uh, configures the sort of configuration uh, that has been decided when it comes to synchronization between these threads, right? Or what how the sequential messaging goes, right? Or how execution is going to be followed, right? Whether how many threads can be executed parallelly, right? For example, within that apartment, for example, right? So this is taken care of as well. And finally, of course, we have marshalling, right? Marshalling, again, as I mentioned, it's a data serialization practice to convert the data into a particular byte stream, right? That can be transferred across multiple apartments, right? So think of it this way: the COM runtime actually blocks, let's say whenever we have let's say when we try to execute or call a method across different apartments, for example, right? Let's say we have multiple apartments and we try to call a method which is in another apartment. The proxy intercepts the data. It serialize from the proxy intercepts the data from our client, right? It serializes this data into a universal stream of bytes, and then it transports it across the apartment boundary. Now, on the server side, or on the in the other apartment, the stub actually catches that stream on the other side. It unpacks it, and then it executes the call on the destination thread. Right. Now, this translation architecture actually guarantees that process and threading boundaries are strictly respected. Right. This keeps the complete COM runtime much more stable. Now, of course, we are executing quite a lot of methods over here, right? These could potentially be sensitive. This could result in command execution, for example, as well, right? So we need, how does the COM runtime take care of its security as well, right? So first of all, we have authentication, right? I mean, the COM runtime does not handle logins by itself, right? Instead, it actually hooks directly to the Windows Security Support Provider interface, right, or SSPI. Now, what this means is that before a client can even establish a connection to the COM server, Windows forces the identity check using protocols like Kerberos or NTLM, right? So basically, you can use these protocols to authenticate, right? And then you can interact with the COM object later on, right? Now, this system validates exactly who is making the request, right? And it ensures that anonymous or unauthenticated actors cannot blindly trigger code execution, right, on your system components. Now, next we have authorization. So just because we are a valid user on the machine or on the network does not mean that we have the right to launch or interact with every service on the machine, right? And to prevent this, the COM runtime automatically enforces the access checks using the ACLs or access control lists, right, which are defined in the Windows registry itself. Now, whenever the client requests an object, right, these runtime checks, the COM runtime actually checks these descriptors or these ACLs to verify that the specific user identity actually holds the permissions to actually launch this COM object or execute or invoke a method using this COM object, right? If an ACL check fails, the runtime simply denies the user from interacting with the COM object. Simple as that. Now, finally, we have impersonation. So think of it this way, many high privilege systems, system services, right? They run with elevated permissions like your NT authority system, for example, right? Now, if a low privilege user wants to actually call a method on one of these objects, right, which are high privileged, for example, let's say reading a sensitive file, for example, right, which they don't have access to. Now, there is a major risk, right, that the service might actually accidentally leak the sensitive data, right? It shouldn't have access to, right? Now, COM actually solves this using impersonation. So in this case, let's say whenever a client triggers a method, right, the high privilege server can actually temporarily drop its own administrative access and adopt the security token of the client, and then it executes the requested code using the client's requested identity, right? Of course, let's say your COM server is running with high privileges. It impersonates that security token of your low privilege user to actually perform the action, right? So that action is not performed with too high privileges, right? And then it reverts back to its own token. Now, there are multiple impersonation levels that your COM server can go to, right? And you can actually, so whenever, let's say, a client actually connects to the COM server, the client actually needs to specify how much trust they are actually handing over to the COM server itself, right? So there are multiple levels, right, that the client can set. So the first one is the anonymous level. Now, this is the most restrictive tier. And at this level, the server cannot identify the caller at all, right? It cannot identify who the caller is, who the client is at all. And it cannot access its token at all, right? It's completely invisible to the COM server. So the server basically has no idea who is actually calling it, right? And so what it does is that it actually runs the requested code using its own, its own default context or a guest account instead, right? Or a default or the guest context, right? So of course, this is very secure, from the client's perspective, right? But of course, it limits the capabilities of the server as well. Then we have the identify impersonation level. Now, in this level, the COM server can just inspect the identity of the client that is actually requesting, the method to be invoked, right? And in this case, it can simply identify the identity of the user. However, it cannot use it to actually run the code, right? It will still have to revert to using the default or the guest context, right? It can simply identify the client identity to at least check whether the, let's say the user has the particular proper ACLs to actually, invoke the method, for example, right? Uh, However, it cannot impersonate the user. Then we have the impersonate level. Now, in this case, the server can actually execute tasks, right, using the client's security token. Okay. And finally, we have the delegate level, which goes beyond the impersonate level as well. So in this case, the COM server can actually clone the security token of the client, and it can actually use it across network boundaries as well, right? So this is the idea is sort of similar to the delegation that you very often see in your Active Directory environments as well, right? That a service is actually allowed to pick up a credentials and pass it to another service, right? Uh, Now, a good example, of course, again, will be let's say when a user wants to talk to a web server via COM, and that web server needs to query a backend database, right, on a separate machine using the user's credentials, for example, right? So, of course, pretty common example that you'll see with your Active Directory as well, or Kerberos as well. Now, coming to how to enumerate COM objects. So first method is, of course, good old querying the registry keys, right? Your COM objects are present in the H key classes root and then the CLS ID, right? Where they are mentioned by the GUIDs, right? You can check out your COM objects through there. Then you have your Windows Management Instrumentation, right? Or WMI. We can query the Win32 underscore COM class, right? And this will give us the COM objects on the machine as well. And finally, no, there are much more options. And the best of all worlds, we have the OLEview.NET tool, which was made by James Forshaw. This provides much more capabilities than, of course, simply enumerating. You can actually use OLEview.NET to actually create an instance directly from GUI and invoke methods as well. Okay. And this brings us to demo one. So quite a lot of theory, I know, quite a lot of slides so far. Now let's jump into a little bit of demonstration. So we are going to spin up our own COM server, right, and interact with it. So let's check this out. And let me just share the screen for this. And okay, I think the screen should be, the PowerShell window should be visible now. So let's just, so I'm in this folder /files, right? Now within this, I have a simple .NET library, right? Or a class library, right? So of course you can implement your COM server in multiple languages, right? As long as they can build a DLL or an executable. Um, Now, it is a little bit complicated when it comes to C++. It is very straightforward when it comes to using .NET, right? So let's just take a look at a simple .NET demonstration of a DLL, right? Which we can host as a COM server. So within this folder, I have, first of all, the simple COM object.cs and the isimple COM object.cs, right? So this is our COM class. If you could remove the pen, that would be great. Let me just, yeah, thank you very much. Okay, so you have the COM class as well as the COM interface, right, which are implemented. So let's just take a quick look at the code as well, right? So first of all, we have our simple COM object.cs, right? This is going to be our COM class. Now this is going to have the core functionality of our COM object, right? However, keep in mind that this needs to be exposed through an interface, right? Which is responsible for your V tables, right? Virtual function tables. So we'll check out that in a little bit as well. So we can see that we of course set the GUID, right, for our COM class, which is going to be this right here, B2, C3, D4, all the way to 7, 8, 9, right? Now you don't need to worry too much about these values yet, right? I would recommend that you take a look at deeper deeper look into each of these lines a little bit later on. I just want to showcase the components that you'll often see as as an attacker when you're enumerating a system, what that looks from a developer's standpoint, right? So we have our prog ID as well, right? Which is of course our human readable string, which is mapped to our CLS ID, right? So this is going to be the mapping, right? Which makes it easier to interact with the COM object, right? You don't want to remember this long GUID, right? Now then we can see that this simple COM object class is implemented through the COM object interface, right? It implements this interface, right? And first of all, we have our string GUID. We can ignore that. What we are interested in is in these functions right here, right? So we have the greet function and the add numbers function, right? So these are the functionalities that this COM class implements, right? Now, how is this implemented through an interface, right? So as I mentioned earlier, that a COM interface, the interface needs to have its own identifier as well, right? The IID. So this over here, we set up the IID, right? And then now you'll see something like this. So when we declare this interface, right, we have this iSimple COM object. Now you'll see this, okay, we have the declarations for our methods that we want to call, the greet and the add numbers, right? We have the declaration for them, but you'll also see this disk ID as well, right? 1, 2, and 3, right? Now this is the dispatch ID, right? So of course, we have our virtual function tables or V tables, right? Which are used to look up the functions, right? Now, let's say whenever you call these functions through PowerShell, right, it will sort of look through the V tables, right? The COM runtime will then look through the V tables, right? However, if you actually use a sort of different component, for example, VBS, right? So you can actually interact with COM through Visual Basic scripts as well, right? Now, in that case, instead of using the V table, it directly finding the addresses, it actually uses this dispatch ID, right, or which is just an integer to actually represent the functions, right? Whenever you use a VBS script, which I'll show you in a bit how to interact with it as well, right? Whenever you use a Visual Basic script, for example, it actually uses the dispatch ID to find out which function needs to be invoked, right? So this is very often implemented as well, right, in interfaces. Now, how do we actually register the COM object? So first of all, we need to build the binary, right? And that, just copy the command. So first of all, we need to actually build the DLL, right? So I'm simply going to build a release executable. Now I already have it. So let me just show it to you in bin x64 and then release and 48. Yeah. So you'll see the simple com demo.dll over here, right? Now to register this, we can use the regasm command, right? So register assembly basically, right? So we can use the regasm command. Now with this, we need to pass the path of our DLL library, right? And then we need to specify the code base flag in our case, right? So it very often, whenever we try to register a COM object, it actually tries to spin up quite a lot of code itself as well. Now, when we specify this /code base, it actually mentions that only use this DLL for the com server, right? Only and only use this, right? Okay. Now, one thing to note is that this command needs to be run. Of course, reg asm, I believe, should not be present directly. Yeah, you'll see that reg asm is not recognized, right? Because this needs to be run from your, it needs to be present, right? Now, this comes shipped with your x64 native tools command prompt, right, for the Visual Studio 2022. So let me show that as well. Let me just share that real quick. Right now, if I run this command from here, oops, right, and this will register. You can see that assembly type, assembly exported to the TLB, right? As I mentioned, that it converts it to a type library as well, right? When we try to register the COM server, and then we can see that it says that it was registered successfully, right? So our COM server is present. Now let's try enumerating this. Okay. So as I mentioned, we have multiple ways, the registry key as well as WMI and finally OLE as well, right? So first, let's take a look at regedit real quick. Right now, I already have this open over here. So we can see that in the HKey classes root registry key hive within the CLS ID, we can actually see our CLS ID, right, for our COM object B2, C3, D4, right? And within this, we can see that we have a subkey for inproc server 32, right? Because we have our in-process server over here. And the code base points to the simple com demo.dll, right? Our .NET assembly, right? Which we're using for the com server. And just like that, we can enumerate this using WMI as well. Let me show that. Now for this, you can use a one-liner like this. So you can we can simply query the sim-v2 namespace for the win32 underscore com class, right? So if I run this, and we're just going to print the name component com ID and the description as well. Now this will actually give a pop-up. So let me share that as well. Right. So this will create a grid view like this. And within this, we can look for our COM object now. For example, simple COM demo, right? So we have our simple COM demo over here. Okay. And we can see its GUID as well. Okay. And finally, we have our OLEview.net. Share that as well. Right. So there we go. So this is our OLEview.net, right? Made by James for sure. Now, we want to go to this CLS ID tab. If you want to try it out yourself and you don't see it, simply go to registry and click CLS ID, and this will open this window for you. And let's look for our simple com. Okay, there we go. So it found our simple com demo, right? Our simple com object. And within this, we can actually see the IUnknown interface, right? Which needs to be present, of course, for every com object. And then we also have our iSimpleCom object as well, right? Now, I'll show you how to interact with this COM object in PowerShell. Since we already have oleview.net open, let's interact directly with it. So with GUI, all I need to do is simply click create instance, right? This will create an instance. It will basically instantiate an object, right, of this COM class. And then I want to interact with this iSimple COM object interface. So over here, I'm just going to open dispatch, right, the dispatch table, and we can see multiple functions over here, right, equals, add numbers, right, greet. Let's try out the greet. So I'm simply going to double click, and now we can see that it takes in a string as an input. So for example, let's just say alt-sec, press OK, and then we can simply invoke the method, and this will give the output as a string, right? Hello alt-sec. This message came from a COM object written in C#. So this is somewhat how you can use oleview.net to sort of interact with the COM objects directly from GUI, right? Now there are you can look through quite a lot of crucial information as well, right? So for example, your CLS ID, right? And if I go to properties, you can see quite a lot of things, right? In proc server 32, right? Now you'll notice that in the inproc server 32 over here, we see mscore mscore right? Instead of our DLL's name. Now, the reason behind that is that whenever the COM runtime, whenever we instantiate an object for this class, right, or an inproc server 32, it actually triggers the COM runtime through this mscore e.dll, and this in turn will trigger our DLL, right? It's not like a DLL triggers directly, right? However, you'll find your DLL mentioned in the .NET tab over here. So this DLL gets executed later on through this DLL. And let's take a look at how to do this through some other methods as well. Here we go. Now to interact with our COM object through PowerShell, quite straightforward. All we need to do is create a new COM object, right, of a type with our prog ID, right, our human readable string. And then we can simply invoke the method, right, the dot greet, and whatever word we want to provide as a string. For example, hello world, right? Just like we did through our oleview.net, right? Now, as I mentioned, we can use the VBS script as well, right? A Visual Basic, you can trigger it through multiple ways, right? You can make a visual, macro, right? You can trigger this COM object through that as well, through your Word documents. Then there's many ways, right? That's the purpose of COM. So now next we have this com.vbs. So let's just give this a read, right? So we simply said create an object of this type, right? And then we echo the message which we get through the greet function, right? Now to execute it, we can use C script and simply provide the com.vbs, and we can see that it triggered the function, right? This is how you can create your own COM objects, register it, and enumerate and interact with them as well. Let's get back to the slides. Right. Now, so we've seen how we can register our COM object and how we can interact with it as well, right? Through multiple ways. Now let's start going into a little bit on the red side, right? I think that's enough, internals and development, right? Let's talk about some abuses. But before that, why do we even want to target comp, right? Let's first step in, let's first step fully into the perspective of offensive operations and defense evasion, right? So security agents like your EDRs, antivirus engines, they heavily weigh the reputation of the binary which is actually initiating the actions, right? You'll very often see the alerts based on parent-child relationships as well, right? So, for example, if you run, let's say if a known hacking tool or like an untrusted script, tries to spawn a shell or access a network socket, right? This will trigger your security filters instantly, right? Uh, so attackers actually abuse COM to break this chain, right? This parent-child chain, right? Instead of executing the actions themselves. So, for example, uh, run DLL32 is a very popular LOL bin, right? To execute DLLs, and then you can call any function that you want, right? So, for example, run DLL32 malicious.dll, and then after that a comma, and then you provide whatever function name that you want, right? Now, this, of course, is very heavily detected, right? I mean, it's not a new thing anymore, right? Even though it is a low pin, right? It might have a legitimate purpose, right? EDRs are not going to let this slide, right? Now, how COM changes this is that instead of executing the action ourselves, right, or as the attacker, instead of executing this action manually, the attacker actually payloads, the attacker's payload actually asks the native COM runtime, right, our COM runtime to do it for us, right? We actually request the COM runtime to trigger that particular binary, right? And then execute our malicious library or executable, right? Now, since the COM runtime is, heavily trusted, right? Right, it uses trusted processes as well, and the flow of execution looks much more normal, right? The security agents actually view this request as a legitimate operation, right? So, for example, a COM object, let's say there's an instance that whenever you instantiate a COM object, right, it automatically triggers run DLL32 with a certain set of DLLs, right? You can simply modify that DLL, right? If it has a writable path, right? You can modify that DLL, and then whenever that COM instance is triggered, it will automatically execute run DLL32, and then it will in turn execute your DLL, right? And that will be no problem at all, right? Because it has been executed through your COM runtime, right? It looks much more legitimate, right? Uh, so this basically uses, you could say, COM as a blind proxy, right? It tricks the security software into like greenlighting malicious activity, right? Because the initiator is a trusted application, right, or a trusted component. Now, in case of out of process instantiation, right, or out of process COM servers, the COM runtime forces your trusted binaries again, right, like your svc host.exe run DLL32 or DLL host to spawn a target to act as the parent process, right? In case of out of process, you might have an executable, so you can spin up a service binary, right? And then it will run through svc host.exe, right, and then it will look just fine. Okay. Now, uh, another really good advantage is bypassing command line detection as well, right? So whenever we instantiate a COM object, we actually don't pass the command line arguments through a shell, right? We don't pass the command line arguments through on our PowerShell or Windows command line, right? Instead, we interact with the objects methods, right? And we invoke them strictly in memory through the virtual function table interfaces, right? So process creation logs do get formed, but they look much more cleaner, right? They don't have any malicious arguments within them. Now, coming to execution through COM, right? That's what we want to do, right? We want to execute uh, commands through component object module. Now there are hundreds of COM objects that will actually allow you to execute commands, right? These are just some of the more popular ones, right? You can use wscript dot shell, for example, right? Now this wscript dot shell has a run function which will allow you to run your commands. Then you have your shell.application. Shell.application actually exposes a function called shell execute that will allow you to run the commands, right? Uh, you can use your office automations as well, right? Your within your office macros. Then you have the Microsoft Management Console, right? Or MMC as well, right? Now with MMC, you also have the execute shell command method, which is exposed as well through the interface. You can use that to run your commands as well, and then the list goes on, right? However, and this actually brings us to the demo of these executions as well. And we're just not going to show these mainstream ones. There's a really interesting one, which is actually very good for lateral movement as well. And that actually utilizes the wsman.automation com object, which is responsible for your WinRM, right? WinRM, of course, much better for moving laterally throughout the network as well, right? So let's check out some of these samples. Right. Let me just share the correct screen. This should be fine. So the first instance, for example, is using the wscript.shell, right? We can create an instance of the wscript.shell com object, for example, and then we can use it to simply run whatever commands that we want using the run function. And this is going to be the call, right? We simply call the run and we use it to run whatever command that we want. And this will pop the calculator for us. And I believe this will not be visible. Let me share that. Right. So this will pop the calc for us as well. And let me show you some other examples of this as well real quick. And then I'll show you the wsman.automation.com object, which is actually useful. These are, of course, very popularly known, right? And these will pretty much instantly trigger detection for you, right? So these are more of a demonstrative purpose. You're much better off not using them for an engagement. Okay, so we can use the shell.application as well. And this will pop up the calc just fine for us as well. Right. So we simply call the shell execute method from our interface. And this again pops another calculator. Right. I believe I'll have to share that one again. But anyway, let's move on to using the wsman.automation com object, right? That is the interesting one. So first of all, since I'm showing this on my host laptop, right, which is of course connected to a public network, I need to first of all enable WinRM, right, or PowerShell remoting on my system, right, before I actually use it. Now you'll see this very often enabled within private networks. So what if you want to try this on your own system? First, you need to actually set your network profile to private, right? So We just clean this up a little bit. Okay. Now, what you need to do is you need to actually set the connection profile as private, right? So, let's say if you're on Wi-Fi or a public network, you'll need to, it will by default be a public network, right? Let me run get net connection profile as well, right? So I have already configured it to private, right? So for example, but in your case, if let's say if you're using it on your host laptop and you're connected to a Wi-Fi, right, you'll very often see private, public written over here. So you need to first convert it into a private network, right? Otherwise the service won't start actually. And then next we need to enable PowerShell remoting. Let's copy that. There we go. Okay. So we simply need to enable PowerShell remoting. Now, why? Because we are going to be using PowerShell remoting or WinRM behind the scenes, right, to actually execute commands. Okay. Now, of course, in an enterprise network, there is a very good chance that you'll already find PowerShell remoting enabled, right? Of course, it's very commonly used by system administrators to manage machines in environments. Okay. Now, let's start using the wsman.automation com object. So first, we need to start by setting up some parameters. So first, the command that we want to execute. And for us, I want to execute the calc.exe. Then the host that I want to execute it on. So the great thing about this is that you can actually use it to run commands remotely as well. Now, why is that? So the idea behind using the wsman.automation com object is that essentially we interact with the com object, then we create a connection string to to connect to the WinRM service, right, over the network, right, and then we execute commands through it, right. Now, over here, I'm just going to show you on my local machine. However, you can actually construct the connection string with any credentials as well, right? You can specify whether you want to specify plain text credentials or you want to pick up the credentials from Gabros. This is actually something that we show in the newly updated CRT course as well, right? So we recently updated it to use, COM for lateral movement as well, right? And over there, we actually showcase how you can actually, pass uh, credentials, right? Explicit credentials to actually, utilize COM with lateral movement as well. But anyway, for now, uh, I want to run it on my local machine. So the host name is going to be localhost. Then I want to start creating my session URL, right? So this will act as my WinRM session, right? Where I can send commands. Okay. Next, we are going to create or we're going to instantiate the com object wsman.automation, right? We're going to create an instance. We're going to create an object. Right? Now, next, we want to set up some connectivity parameters. So we're going to run the create connection options first, and then we can create our session. Now you can look through these commands in detail a little bit later on. I'll share them as well. Now, we have our WinRM session established over here, right? And we want to send the commands, right? Now, to send the commands, we are actually going to be using the win32 underscore process com object, right? We're going to use a WMI to run the commands through our WinRM session. So for this, we actually need to make a SOAP call, right? It uses SOAP API behind the scenes, right? The XML HTTP requests. So we first need to target the win32 underscore process WMI class, which will allow us to spin up new processes, right? So this is going to be, first of all, our resource. And then we need to set up our parameters as well. And this is what it will look like. So this is the command that will send, right? And whatever the dollar command will go, right? This will be a command line argument, which is going to be calc.exe. So let's set this up as well. And now we can simply run this. So we can simply go ahead and run the create method from our win32 underscore process class, right? So win32 underscore process class has the create method, which allows you to create new processes, right? If you are using WMI over here, you are restricted to whatever class you are using and what purpose it serves, right? So I'll demonstrate some others as well. Now, if I run this, this will actually spin up a new calculator for me as well, right? Guess it might not have been visible through there, but I guess take my word for it. So maybe we can write some other command as well. Right. So let's say if I want to change the command, let's say, for example, I write notepad and then I need to change the parameters and simply run the response, right? And this spawned a notepad process on my VM again. Let me share that. Right. So for example, this was the notepad process that just got spawned behind the scenes, right? When I triggered this dollar response, right? Now, there are some limitations to this. So if I look at the response, you can see that it's some XML data, right? By the way, we can see now if you want to confirm, let's say if you're executing it remotely, right? Now, of course, I'm executing this command on my local machine. I can see that the calc popped up, the notepad popped up, right? But I can't see if I execute this remotely. Let's say if I pass the credentials and pass another IP address, right? How do we identify if it actually works? Well, the XML response actually has the process ID of the process that spawned as well, right? For example, this 76496 over here, right? And a return value of 0. This means that the process spawned successful, right? Now, there are multiple techniques that you don't just need to use the win32 underscore process class. So there are multiple, there are multiple WMI classes that you can use. So for example, you have Win32 service. This will allow you to create a service, right? All of these will actually allow you to create a service on that, on the system. Then you can also create scheduled tasks by using the Win32 underscore scheduled job, right? So there are multiple options, right? I would definitely recommend that you try, exploring, executing through these, in multiple ways. This was our demo number 2. And let's get back to the slides. Right, we're back. Now, so we discussed some techniques for execution, right? There are multiple ways. Of course, the wsman.automation in particular is very useful. I think it should get you just fine in an MD environment, right? It should get you just fine. At least when it comes to the lateral movement alerts, you should be pretty safe. Then there are, however, many more targets when it comes to COM objects. So another popular abuse is abusing the auto-elevated COM objects. So this in particular is used to bypass UAC or user account control, right? So the thing is that to keep the user experience smooth, right? And prevent endless pop-ups, right? Microsoft actually designated a list of trusted and built-in COM objects that are, so you could think of them as pre-approved, right? They are pre-approved to automatically escalate to a high integrity session without any prompt to the user, right? And whenever an application calls one of these specific objects, right? Windows actually makes the decision behind the scenes, right? If the calling process is running in a standard a standard security token, right? A medium integrity, right? Let's say if it's running in medium integrity, right? The operating system, if it realizes the COM object actually has, approval for auto elevation, right? The operating system actually grants the fully administrative system to that COM object without actually ever prompting a UAC, without actually popping the UAC prompt, right? To ask the user for permission, right? So even if you run from medium integrity, for example, uh, you get the high integrity access to that COM object, right? And now if that COM object supports a method which will allow us to run, let's say, commands, right? For example, the shell execute, just like we saw earlier, right? That will allow us to escalate our, that will allow us to open a high integrity command prompt session, for example, right? And therefore bypassing UAC, right? Now, uh, we discussed that there is one requirement that auto approval needs to be enabled, right? Now, to abuse this, the attackers actually use something called an elevation moniker, right? To instantiate, a higher integrity COM object, right? So this elevation moniker actually follows this format: elevation colon administrator exclamation new colon and then the GUID of the class that we are targeting, right? So you'll recall that I mentioned that to instantiate an object, we actually call the co-create instance, right? Um, co-create instance along with the CLS ID, right? To actually create an instance. However, when you want to use this session moniker, right? This string, right? So you can actually use this string to actually create the instance, right? And whenever you use this elevation moniker, instead of using the co-create instance function, use the co-get object function, right? You can't use co-create instance with these monikers, right? A moniker is basically a specialized string URL, by the way, right? It's just a specialized string URL, right? Which tells the COM subsystem, how to bind and initialize or instantiate the object, right? It's basically just a string, right? Now, by leveraging this elevation moniker, a script or an executable which is running in a medium integrity context, right, can actually tell the runtime that, hey, I want to launch this specific pre-approved class and I want it instantiated with the administrative rights, right? Now, because the target class is in the whitelist, right, it is already pre-approved and we are using an elevation moniker, right? It will easily give us administrative context to the COM object, right? Now, again, the requirements when it comes to abusing these auto elevated COM objects, the COM class needs to be pre-approved, right? The target CLS ID needs to have the auto elevate property, right? It needs to the particular property is actually called enabled and its value needs to be set to 1, right? Then there is another requirement, and that is that the binary which is actually requesting this elevated access, right? Uh, let's say whenever I want to request this administrative context to the COM object, the client or the binary which is actually requesting this object, it needs to be Microsoft signed, right? It needs to be a trusted and Microsoft signed executable, right? Uh, so that is another really important requirement, right? And finally, the requesting binary, as I mentioned, it needs to be Microsoft signed, and it also needs to be in a secure system directory. So for example, your C Windows 32, right? Or anything else, right? C program file, something like that. It needs to be in a secure system directory. Okay, so these are the 3 requirements. Now, there is a very popular UAC bypass which has been built on this concept, which is the ICM Lua util UAC bypass, right? Now, this targets the TMS-TP Lua COM service, right? And it has this GUID starting with 3E all the way to C7, right? Now, this registry, again, this has an elevation registry key, which has the enabled value set to 1, right? Now, There are multiple public exploits available for this UAC bypass, by the way. One of them is made by an author called Zero X Lane, right? It's published on GitHub, right? Now, the idea, first of all, is that we take our malicious binary, right? And what we do is we actually the our own binary, it actually modifies its own process environment block to impersonate a trusted binary, right? Now, there was one block that I saw where a threat actor was impersonating DLL host.exe. The proof of concept by 0x lane on GitHub, it actually impersonates explorer.exe, right? So our malicious binary actually modifies its own process environment block to imitate explorer.exe, right? Which of course meets our requirement that the binary is signed and it's protected, right? And of course, our class is approved, right? This CMS TP Lua com service, right? This is of course pre-approved, which we'll see in a little bit as well, right? And of course, since we have all of the requirements met up, the binary modifies it, right? And then it invokes the shell exec function from the cmlua.dll, right? So the server runs as an in-proc server 32, right? An in-process server cmlua.dll, and it exposes a function called shell exec, right? Which allows you to basically execute commands, right? And that way we can execute commands in an elevated context, right? So let me show this to you as well. Let me share OLE view again. Go. Okay. I think oleview.net should be visible. Now let's just close these tabs as well. Now in CLS ID, I'm going to look for CMS TP Lua, right? This is the COM class that we are targeting, right? And within this, we can see the interfaces as well, right? The ICMTP Lua and ICMTP Lua 2, right? And if I just hover over it, you should be able to see that the vtable address, it actually mentions the CMS TP lua.dll, right? So that is the DLL associated to it as well. Now, if I go to the properties of this class, okay, the CMS TP Lua class, if I go to its properties, first of all, again, we can see the in-proc server 32 and the lua.dll. Now, we can also see an interesting elevation tab over here as well. And within this elevation tab, you'll actually see that enabled equal to true and auto approval equal to true, right? So that means that this is in fact vulnerable to auto elevation and it can be used for UAC bypass, right? Now, let me show this to you in registry as well. I'm just going to copy this registry key. And let's switch to the registry editor. And I've just copied the GUID. And within this GUID, first of all, you'll see, of course, our in-proc server 32, which points to cmstplua.dll. And we also have elevation, right? And over here, we can see the enabled value is actually set to 1, right? Now let's try abusing this. And let me show you the code real quick. Right? So my Visual Studio is visible as well. So this is the bypass UAC project by 0x Lane, right? Now, we're not going to go too deep into the code. What I really want to show you is, first of all, the elevation moniker, right? We can see that, first of all, the author has defined a global variable, right? Elevation administrator new, and then after this, they'll input the GOID, right? To complete the elevation moniker. And this also has the masquerade pep function as well, right? To actually modify the process environment block all the way to explorer.exe, right? So within this explore masquerade pep, you'll see that we actually modify our pep, right? To explorer.exe, right? To imitate its path as well as its binary name as well, right? So that it can pass the checks. Now, for the execution, you can simply build the binary, right? There are multiple options. You can either use the .NET binary or the native CPP binary, and you'll get this output, right? You'll see some executables in TLS, and pretty much all you need to do is just run the execution. This is just a message box that has been inputted in, entered into the program for debugging purposes. We can ignore this. This is not a UAC pop-up, right? And this spins up a system, a shell with high integrity, right? And this is how you can bypass UAC. Let's switch back to the slides. Right. Now, just like for UAC, we can actually use COM for persistence as well, right? We discussed many key, CLS ID registration keys, right? These can be actually targeted to establish persistence. Now, so first of all, we have the registry search order hijacking, right? So as I mentioned that the HKCR or HKey classes root registry key hive is actually a mix of HKCU and HKLM, right? The HKey current user and the HKey LAN manager. Now, the thing is that, of course, you'll recall that if we try to instantiate a COM object, the COM runtime goes back to the registry key to map the GUID to the binary, right? The thing is that the HKey current user hive actually takes precedence over HKey LAN manager, right? Or HKLM. Now you might know that the HKey current user corresponds to your current user, right? And the HKLM is for system-wide configurations, right? Which are usually done by administrators, right? So what we can do is that let's say we have a CLS ID or a COM object which has a CLS ID in the HKLM, but it does not have a CLS ID in the HKCU hive, right? So what we can do is we can duplicate that CLS ID and make a new COM object in that HKCU hive and place the malicious DLL or executable, right, in the values, right? And simply, whenever that COM object is instantiated, the COM runtime, instead of running the legitimate binary from the HKLM, it will actually run the binary from the HKCU hive, which is maliciously placed by us. Okay. And this is your registry search order hijacking. Then you can, of course, modify the inproc server 32 variable itself, right? If you find any, well, there are going to be hundreds of them, but if you find any inproc server 32 keys, right? Of course, even as a low privilege user, you can modify the HKCU hive, right, for your own user. And within that, you can actually simply replace the path for that malicious DLL, right? I mean, simply replace the DLL and that's it. You're good to go, right? Your malicious DLL will be executed. And then finally, we have the tree test hijacking, right? So again, as we discussed, that the tree test key is actually used for rerouting, right? Or redirecting the CLS IDs, right? Let's say you have a COM object with a CLS ID. You can actually enter a tree test key, right? And point it to another CLS ID, right? And whenever that COM object is instantiated, the another third-party COM object will be instantiated instead, right? Again, as we discussed, this is used for backwards compatibility. Right? Now, what we can do is we can simply point a legitimate COM CLS ID to our attacker-controlled malicious CLS ID, right? That way, we don't have to modify the registry keys of an already existing COM object, right? So, for example, let's say CMSTP Lua, right, which is used for UAC bypass. It might be heavily monitored, right? By the way, Elastic does have rules, multiple rules, right? Elastic EDR has detection rules for this UAC bypass. So instead of modifying that UAC's DLL path or anything else, we can simply point it to any another COM object, right? And that will be a much more safer manner. So that way, these are some of the ways that you can utilize COM for persistence. Now, a little bit for our fellow blue teamers, right? Since we have discussed quite a bit of attacks as well. So how can you protect yourself against these COM abuses? Right? Well, the first is, of course, using the good old Sysmon. Right? Of course, Sysmon again is the Swiss Army knife of logging. Right? It collects so much telemetry. Right? Um, and of course cleanly lays them out with event IDs. So what can you look out for in Sysmon events? Well, you can look out for process creation events, which are from event ID 1. Now we have mentioned that process creation from DLL host, but of course not just DLL host, run DLL 32 and SVC host as well, right? From with any unusual arguments, right? Also, look out for any DLL load operations, right? Which are your image load operations when it comes to Sysmon through your event ID 7, right? Look out for DLL loads through run DLL 32 as well, especially from writable paths, right? Of course, it's pretty common for COM to load the DLLs from your system paths like your C Windows System 32 and paths like that. But user writable paths, which could be dangerous, right? If any of these components are loading those DLLs, that might be a malicious behavior. Then also look out for registry modifications and creations, right? As we discussed that, a registry is a core component of the COM architecture, and so are its abuses, right? Just like the hijackings that we discussed earlier. So keep a track of your HKCR registry key hive, and of course, within these CLS ID keys within those, right? Keep a track of the modifications within the keys that we just discussed earlier. Now, you can also utilize ETW or event tracing for Windows, exceptionally good for collecting telemetry as well. You can utilize the Microsoft Windows COM runtime provider, right? Now, this collects quite a lot of telemetry as well. Especially, this also collects the process creation logs as well, right? So those are especially useful because it also, collects the parameters. Well, not exactly the parameters that go through our binary, but rather the GUIDs as well, right? So whenever the process is created, this ETW provider actually captures the GUID as well, right? Which COM class is actually triggering this process creation. And finally, make sure to maintain a known good inventory of your active COM registrations that are present on your systems, right? Keep a track of the COM objects and GUIDs, which are very commonly abused by malicious threat actors as well. Now, it's not over yet. So we just went through some monitoring and detection techniques, right? What you could do as a defender. And however, COM just does not end here, right? There is quite a lot more to it, right? This is just scratching the surface. Now, after this, you can, of course, take a look at DCOM or distributed COM. Now, this basically extends your COM architecture across network using remote procedural calls, right? This is very commonly abused to execute commands across servers as well. Now, one really good example of abusing DCOM is cross-session activation. So this is something that we cover very, very heavily in the updated CRT course as well. We perform lateral movement across, across our Microsoft Defender for endpoint machines through this cross-session activation. So the idea behind using cross-session activation is a special type of session moniker, right? We just discussed session moniker, right? Now there is a particular type of session moniker called session to session activation with a session moniker. Yes, this is the official name in the Microsoft documentation. So what this allows you, this type of session moniker actually allows you to create a COM object in a different logon session than the caller. Now, what is this useful for? So first, let's set the scenario first. So let's say you are a local administrator on a machine, right? Now, of course, you want to you want to get credentials, you want to gain access to other users on the machine as well, right? Of course, you want to target else's, right? But targeting else's is getting more and more difficult, right? Especially with credential card, right? It's pretty much untouchable with you can't dump your AES keys, right? With the credentials, with the presence of credential card, right? You can maybe go for DP API keys, but not for your AES keys and good old NTLM hashes, right? Those are protected by the isolated LSA ISO process, right? So how about let's say you have local administrator on the machine. Instead of trying to dump the credentials, what we can do is we can utilize this cross-session activation to actually execute code in the context of any other user that has an active session on the machine, right? So this is what cross-session activation allows you to do. It allows you to create a COM object in a different logon session, right? If there is an active session, right? If let's say a user logged in, right? You can actually create a COM object in that. And then of course, if we find a way to invoke commands, then we can simply gain code execution, right? Now, one thing to note is that it requires the run as interactive user object activation mode configured, right? In the COM object itself, right? So we can only target COM objects where we have the run as interactive user object, this activation mode configured. Now, if we manage to find one, we can actually execute commands in the logon session of a different user on the machine, right? Now, a really solid and example of this is the speech runtime move by Secure This Shit, right? Of course, a very popular researcher. Now, this actually abuses the speech named pipe com, right? And it spawns. So what basically happens behind the scenes in this tool is that let's say you create a cross, session to session, this session moniker, right? And what happens is you find out the session ID that you want to target, right? And whenever the object for this speech named pipe com is instantiated, it actually spawns the speech runtime.exe, right? Whenever you create an object, it automatically spawns this speech runtime.exe, right? Now, this speech runtime.exe in turn is dependent on multiple DLLs, right? It loads multiple DLLs for its purposes. And this binary is actually vulnerable to DLL hijacking, right? There are multiple DLLs which are not found. So as an attacker, what we can do is we actually let's say craft a malicious DLL, right? And we place that DLL in that particular path, right? Where the speech runtime.exe. So let's say the speech runtime.exe tries to load C and then temp and then DLL, right? Now, of course, as a local administrator, what we can do is we can try to simply copy our DLL that we want to be executed to this path, right? And we simply copy it to this path. Then we trigger this speech named pipe com object, right? This will in turn spawn the speech runtime.exe, and then it will execute our DLL. Now, the best part, of course, it looks like just like a normal execution flow at all, right? We are not using run DLL32 ourselves, right? We're not executing code manually. All we have really done is simply just perform a file copy, right? We just copied our DLL over there on that target system, right? And then just instantiated the COM object, right? So super useful, especially in evading Microsoft Defender for endpoint, right? At least it's worked really well for us, right? And let me just show this to you real quick in action as well. Let me just share the command prompt. Right. Let me just go to the folder with speech runtime move. Now, I'm just going to execute it locally. So first of all, we want to actually enumerate what sessions are present on our machine, right? So I'm going to run mode enum, and the target is going to be localhost. Let's run this. Oops. Let me just run this directly. There we go. So this found out the sessions for us, right? We can see session ID 0 for services. We don't care about this. And we can see a session ID 1, right? With for the user altsec 5, altsec, right? Now, of course, in in let's say lab or in the CRT lab, of course, you'll see multiple users listed, right? So that will allow you to execute commands in their environment as well. Now, all now we want to spawn a calc once again, right? So simply give the speech runtime move. Now this time the mode is going to be attack. Target again is localhost. The DLL path will be C Windows temp ponton DLL, right? So this is going to be the DLL that's going to be copied. The session that we are targeting is session ID 1. The username again is altsec, and the command that we want to run is cat.exe. And if I run this, oops, okay, I just need a dot slash, and let's copy the rest of it. So, and you might have seen a command prompt pop up, and at the end it actually gave a calc as well. So this is the calc that actually popped up behind the scenes, yes, right? So, but let's try to understand what happened behind the scenes, right? So it the speech runtime move tool actually saw our command, right, that we want to execute. It converted it into a DLL, right? It automatically created a DLL. It wrote it to the folder that we requested, right? It dropped the DLL to the path again, right? And then it modified the for COM hijacking, it modified this in proc server 32, right? It wrote our path to it, right? It set up the COM hijack. And then when the COM object was spawned, right, or instantiated, you can see the co-create instantiated successes succeeded, and it targeted the session 1, right? Now keep in mind that in targeting session 1, right, when we create the session to session activation moniker, we also used the co-get object once again, right? So behind the scenes over here, it's also using co-get object once again, right? There are multiple tools that allow you to execute it in a similar fashion, right? Uh, of course, very useful. What I would definitely recommend is that you try to look out for for COM objects that actually allow you to perform this cross-session activation as well, right? So yeah, pretty useful technique. And let's get back to the slides then. Right. So this is somewhat of a further studies as well, right? I would heavily recommend that you dive deeper into DCOM and cross-session activation. And that will do it for the webinar. Thank you everyone for joining the session. Please feel free to provide the feedback that helps us improve with the content. I hope you enjoyed and it was the content was useful to you. Of course, please make sure to join the Altered Security Discord server, and feel free to drop your questions there. And yeah, thank you all for joining. Let me see if there are any questions in the chat. So there's one question: who has the permissions to add ACLs for the COM object? So that will pretty much be the user who is, I guess you could say, registering the COM object. It's more of a ACLs on the binary itself as well, right? So those ACLs are particularly specified in the registry itself as well, right? Those ACL rights. Basically, the user who is pretty much like configuring the COM object as well. Is there something like LOLCOM, similar to LOL bins and old bash? I'm not particularly sure if there's a sort of list where sort of vulnerable COM objects are maintained. You know I do recall a repository. I'll definitely make sure to drop its link if I find it. I think there was a repository which had a list of interesting, vulnerable COM targets, right? But in my opinion, just like drivers, in my opinion, in case of COM, you are much better off finding, your own personal one. Like, right, dive deeper through oleview.net or look through the COM objects on your system, and then try to find some interesting targets. I hope that answers it. Please let me know if there are any questions. I think we are 10 minutes over the time as well. Uh, all right. Yeah, I think we'll end the session over here. But yeah, please feel free to drop the questions later in the chat as well, and I'll make sure to reply to them. Once again, thank you everyone for joining the session. I hope you enjoyed it as much as I did. And yeah, I hope this sets you well on your COM journey. See you later.